Hello, this is Ms. DB, and we're going to look at the last part of the Chapter 3, Section 4 worksheet in this video. So we're going to start with this number 10, which is a proof. We have some given information to fill in. It says that M is perpendicular to N. These two lines are perpendicular. And then they tell us to use the definition of perpendicular, which you can look up if you need to, but the definition of perpendicular is that the angles are going to be right angles. So the angles that we're concerned about is angle 1, that's going to be 90 degrees, and angle 2 is also going to be 90 degrees. Let's write them both down. Now step 3 says that angle 1 is congruent to angle 2. Well, if they're 90 degrees, they're right angles. I guess I can add a step that says that. And if they're right angles, we learned a theorem back in Chapter 2, Section 6. Let me see if I put it on the more proof worksheet where we combined some of the theorems from 2.6 and 2.7 that said that if you have any number of right angles, they will be congruent to each other. So if they're both equal to 90 degrees, then they're right angles. We could add another step to this proof, and I probably should, that says that then they're right angles. Should we add one more step? I'll call it the 2.B step. Angle 1 and angle 2 are right angles. And that's because of definition of right angles. If they're right angles, they're equal to 90 degrees. And then I'm going to use that angle 1 is congruent to angle 2 because all right angles are congruent to each other. And you could look back at the exact theorem that said that. I moved it a little bit. It's the right angle congruence theorem. All right angles are congruent. The right angle congruence theorem. Right angle congruence theorem. I'm just going to do THM. All right, then I wrote that measure of angle 1 plus measure of angle 2 equals 180 degrees. Well, we have given this picture. And this picture shows that these two angles form a straight line. So I can go ahead and add measure of angle 1 plus measure of angle 2 together to get 180, or I can just say I can use these two things. I can add these two together and their sum is equal to 180. So the addition property of equality tells us that that is true. And if I have that their measures are equal to 180, then I have that angle 1 and angle 2 are a linear pair, and they're a linear pair of congruent angles because we already said they're congruent. So what I'm trying to prove is what you should end up with on the last step of your proof. All right, so we've got that one taken care of, maybe with an extra step or two. Number 11, you just have to pick which of these statements would not be true if L is perpendicular to M. So I'll let you work through that, look through each one and see if that must be true. And then for these ones, we're going to go back to the theorems that were in this chapter. So here we have parallel lines, and we have that these are, one of the lines is perpendicular to the other one, which means that I could use the theorem that says that if they are perpendicular to one line, it's also going to be perpendicular to the other line. So they're actually both going to be perpendicular, which means then, I'll go ahead and mark that is then perpendicular. So that means that 2x is equal to 90 degrees because this 2x is for the measure of that angle. So you can solve and get what x is equal to. And then the other one, 3y minus 2x is also equal to 90 degrees because if this is 90, then this is also 90. But now we know what x is. So 3y minus 2 times what you got for x equals 90. And then you can continue solving and find y. All right, now this one, let's see what this is. Is this the same thing? We have two parallel lines cut by a transversal. One of them is perpendicular to the transversal. So they're both perpendicular to the transversal. So 6y is equal to 90 because it's already if this side's 90, this side is 90 as well. Perpendicular means any of these angles are 90. So you can solve that for y. And then 5x plus 4y is also going to be, that's also a right angle, so 5x plus 4y is equal to 90. But now we know what y is. So you plug in your value for y that you got over here, and then you solve this and find x. And then let's just double check that the last one is, oh, so this one we only have perpendicular lines. This one's going to be a little bit different. We have two perpendicular lines, so all their angles are equal to each other, but it wouldn't help you to write 2x plus y equals 10x minus 4y because we'd have both an unknown for x and for y. So instead, let's write that 2x plus y equals 90 and 10x minus 4y equals 90. Those are both true statements. So what we have is we have a system of equations with an x and a y in them, and we solve these in algebra. So you need to pick whether you want to do substitution or elimination to solve for one of the variables. We used elimination in the last worksheet, so let's practice with substitution for this one. I'm going to solve the top equation for y. So if I have 2x plus y equals 90, I can easily solve this for y by just subtracting the 2x from both sides. So y is equal to 90 minus 2x. Now I take what the y is equal to and I put it right here for y. So I would have 10x minus 4 times y, but y is equal to 90 minus 2x. And then I still have to write equals 90. So now we just simplify this expression, this equation, and solve, and then we'll find what x is equal to. Let's see, 4 times 90 is 360. Negative 4 times minus 2x would be a plus 8x, and then equals 90. Now when you combine your like terms, this is a plus 8x. We have 10x plus 8x is 18x minus 360 equals 90. And now it's just a two-step equation. You finish solving this, add 360 to both sides, divide by 18, and you'll have what x is equal to. Once you know what x is, put it back up into this equation, y equals 90 minus 2 times whatever that is, and then you'll know what y is as well. So you need to find x and y in order to answer the question. All right, let me know if you have any questions. Thanks a lot and have a great day.